Right now, you are surrounded by glass. There's glass in your hand if you're holding a phone. Glass in front of your face if you're wearing prescription lenses. Glass between you and the weather if you're indoors. Glass carrying the signal that delivered this video to your screen. Glass is so omnipresent and so invisible that you have literally trained your brain to not see it. That's the whole point of glass. It's the only building material whose job is to disappear. You look through it, never at it. And because of that, you have absolutely no idea how much of your life depends on a material you can't even perceive. Glass is one of the oldest manufactured materials in human history. The earliest known glass objects are beads from ancient Mesopotamia, roughly 5,000 years old. The Romans blew glass into vessels. Medieval craftsmen spent entire lifetimes fitting colored glass into cathedral windows, piece by piece, leading strips bent by hand. The recipe is absurdly simple. Sand, soda ash, limestone, heat. You melt sand at about 1700 degrees Celsius, and it becomes a liquid that, when cooled, doesn't crystallize like most materials. It just thickens, freezes mid-flow. Glass is technically not a solid and not a liquid. It's an amorphous solid, a material stuck permanently between states. And we shaped this strange frozen liquid into lenses that gave sight to the near blind, into fibers thinner than hair that carry the entire internet, into screens you touch 1,000 times a day, into barriers so clean and transparent you sometimes walk face first into them at shopping malls. Glass is the invisible architecture of modern life. So let's remove it. At noon tomorrow, every piece of glass on Earth vanishes for 3 seconds. Every window, every lens, every screen, every fiber, every bottle, every mirror, every bulb. Gone. Then, after 3 seconds, all that glass rematerializes. But not back where it was. Not shaped into windows or lenses or screens. It comes back as raw glass. Lumps, chunks, flat sheets pooled on the ground. Solid blobs reformed in place by gravity and surface tension, the way molten glass would settle if you poured it onto a table and let it cool. The material returns. The craftsmanship doesn't. The first thing you'd notice isn't what you'd expect. It's not the wind coming through where your window was. It's not the crunch of your phone hitting the floor. The first thing 2 billion people on this planet notice is that they can't see. Over 2 billion people worldwide use corrective lenses. Glasses, contact lenses, both made from precision ground glass or glass-derived polymers. The moment glass vanishes, spectacle frames are still sitting on 2 billion faces, but the lenses are gone. Anyone whose uncorrected vision is worse than about 20/200 is legally blind. They can see shapes and light, but not detail, not text, not faces at a distance, not obstacles on the ground. For 3 seconds, a quarter of humanity cannot navigate their environment. People are mid-step on staircases, mid-drive on highways, mid-surgery in operating rooms. Surgeons working through magnifying loupes or microscopes for microsurgery suddenly have no optics. Their hands are inside a patient, and they cannot see what their hands are touching. But the vision comes back, right? 3 seconds. Glass reforms. Problem solved? No. The glass that was in your prescription lenses doesn't return to your frames. It returns as a small blob of glass wherever gravity left it. Maybe on the floor, maybe on your cheek. Your frames are empty. And replacing prescription lenses requires optometric equipment that itself relies on glass optics. The autorefractors, the phoropters, the lens grinding machines. All of them just lost their glass components. The ophthalmology supply chain doesn't have 2 billion replacement lenses sitting in a warehouse. Manufacturing new ones requires optical-grade glass blanks, diamond-tipped glass-cutting equipment, and coating chambers. Getting even a fraction of the world's corrective lenses replaced would take months. For that entire period, billions of people are functionally vision impaired. They can't read, can't drive, can't work at any job requiring visual precision. Now look at the building you're in. Every window is a hole, not a broken window with jagged edges still in the frame. A clean, empty rectangle in the wall, because the glass didn't shatter and leave pieces behind. It vanished completely and came back as a lump on the ground below the window frame, or on the floor, or on the windowsill. Your building now has the climate control properties of a parking garage. Every office tower, every apartment building, every house with windows is suddenly open to the outside air. In temperate weather, that's uncomfortable. In January in Chicago, Moscow, or Sapporo, it's a survival problem. Nighttime temperatures in those cities regularly drop below -15 Celsius. Every heated space with glass windows is now an unheated space with gaping holes in the walls. Furnaces and radiators would run at maximum, trying to heat rooms that are functionally outdoors. Energy demand spikes immediately and accomplishes nothing, because you cannot heat a room with no walls. And those aren't small openings. Modern architecture loves glass. A standard glass curtain wall office tower is essentially a steel frame wrapped in windows. The Shard in London is 87% glass by exterior surface area. After 3 seconds, the Shard is a steel skeleton with floors. No exterior envelope at all. Just open-air platforms stacked 300 meters into the sky with office furniture sitting on them. Wind at that altitude averages 60 to 80 kilometers per hour on an ordinary day. Every piece of paper, every monitor, every coffee cup, every unsecured object on every floor is airborne. People working on upper floors of glass-curtained buildings are suddenly standing on exposed platforms in gale-force wind with no barrier between them and a 200-meter drop. But forget skyscrapers for a moment. Think about cars. Every vehicle on Earth just lost its windshield, side windows, rear window, mirrors, headlight covers, instrument cluster glass, and the screen of any built-in navigation or entertainment system. At noon on a weekday, there are roughly 1 billion vehicles in active use worldwide. A significant percentage are moving. Drivers on a highway at 100 kilometers per hour suddenly have no windshield. Wind hits their face at full speed. Dust, insects, road debris, all of it coming straight at their eyes. Reflexively, they flinch, they close their eyes, they throw their hands up. At highway speed, that involuntary reaction lasts about 1 second. In that second, a car traveling 100 kilometers per hour covers 28 meters with a driver who isn't steering or watching the road. Multiply that by millions of highway drivers simultaneously. The 3-second glass disappearance would trigger more simultaneous traffic accidents than any event in the history of the automobile. Now let's talk about the thing nobody sees but everybody uses. Fiber optic cables. The internet feels wireless and abstract, like information floating through the air. But 95% of intercontinental data traffic travels through physical cables lying on the ocean floor, and the core of every one of those cables is glass. Hair-thin strands of ultra-pure silica glass, sometimes hundreds of them bundled together, carrying pulses of light that encode every email, every video stream, every financial transaction, every military communication that crosses an ocean. There are over 500 submarine cables currently active, totaling more than 1.4 million kilometers of length. When glass vanishes, every one of those cables becomes a hollow plastic tube lying on the seafloor. For 3 seconds, the internet between continents doesn't slow down. It ceases to exist. North America loses connectivity to Europe. Europe loses connectivity to Asia. Financial markets that execute trades in microseconds across oceans go completely dark. 3 seconds later, the glass returns. But it doesn't thread itself back into fiber optic strands 5 microns in diameter, arranged in precise bundles, fused at splice points, and routed through repeater stations on the ocean floor. It comes back as tiny beads and blobs of glass sitting inside those cable housings. Every submarine fiber optic cable on Earth is permanently destroyed. Repairing them isn't a matter of splicing a break. You'd need to manufacture and lay entirely new cables. The global fleet of cable-laying ships numbers about 60 vessels. Manufacturing a single transoceanic cable takes months. Laying it takes months more. The queue to restore intercontinental internet connectivity would stretch years. In the meantime, continents function as digital islands. The global financial system, which depends on millisecond synchronization between exchanges in New York, London, Tokyo, and Hong Kong, fragments into isolated regional networks that can't talk to each other. Now the cascade becomes something stranger than just destruction. Laboratory glass. Every research institution on the planet just lost its beakers, its flasks, its pipettes, its graduated cylinders, its test tubes, its petri dishes, its distillation columns, its spectrophotometer cells, its NMR tubes, its chromatography columns. Borosilicate glass, the stuff labs use because it can handle thermal shock and chemical exposure, doesn't grow on trees. Schott AG in Germany and Corning in the United States produce the vast majority of the world's laboratory-grade glass. Their facilities just lost their own glass components. The furnaces that melt borosilicate glass use glass-lined vessels. The quality control process uses glass reference standards. The production of lab glass requires lab glass. This is a bootstrap problem that hits science at its foundation. You cannot do wet chemistry without glass containers. You cannot do microscopy without glass lenses and glass slides. You cannot do spectroscopy without glass optics. Research doesn't pause. It regresses to a pre-17th century capability level until new glass can be manufactured. And manufacturing new glass requires quality control instruments that are made of glass. Medical systems take a particular hit. Billions of vaccine doses are stored in glass vials. Blood samples are drawn into glass vacuum tubes. IV solutions hang in glass bottles across thousands of hospitals in developing nations that never switch to plastic. Microscope slides for pathology. Glass thermometers still in use across rural clinics. Glass ampules containing anesthetics and emergency medications. Hospital pharmacies in many countries still stock critical drugs in glass ampules that you snap open at the neck. All of those medications are now sitting in puddles on pharmacy shelves, mixed with reformed blobs of glass. Contaminated. Unusable. In countries where the pharmaceutical supply chain already runs thin, 3 seconds just wiped out months of drug inventory. Then there's the thing that seems trivial until you think about it for 10 seconds. Mirrors. Every mirror on Earth is glass with a thin metallic coating on the back. They're gone. Bathroom mirrors, car side mirrors, rear view mirrors, the mirrors inside telescopes, the mirrors inside laser systems, the mirrors inside semiconductor lithography machines that etch circuits onto microchips. That last one matters more than you'd think. Modern chip fabrication uses extreme ultraviolet lithography, and EUV machines rely on multi-layer mirrors polished to sub-nanometer precision to focus light at a wavelength of 13.5 nanometers. Each mirror takes months to manufacture. A single EUV machine contains over 100 of these mirrors. ASML, the sole manufacturer of these machines, produces maybe 50 or 60 per year under ideal conditions. Every EUV machine on Earth just lost its optics. No EUV machines means no cutting-edge chip production. No cutting-edge chips means no new smartphones, no new GPUs, no new AI training hardware, no new automotive processors. The semiconductor industry doesn't just slow down. The most advanced nodes stop entirely until new mirrors can be fabricated, polished, and installed, which takes well over a year per machine. Now zoom out to the agricultural layer. The Netherlands is the world's second largest agricultural exporter by value, and a huge portion of that output comes from greenhouses. The Dutch greenhouse sector covers over 9,000 hectares of glass-roofed growing space. Tomatoes, peppers, cucumbers, flowers, grown year-round under controlled conditions that are only possible because of glass. Glass lets sunlight in, traps heat, keeps pests out, and allows precise climate management. That glass is now lumps on the ground between rows of plants. Every greenhouse on Earth is an open field. The crops inside are exposed to ambient temperature, wind, rain, insects, birds. In the Netherlands in winter, nighttime temperatures would kill subtropical crops within hours. Spain's Almeria region, which supplies a massive share of Europe's fresh produce from plastic and glass greenhouses, faces the same problem. Global fresh vegetable supply takes an immediate hit that lasts until greenhouses can be rebuilt, which requires manufacturing flat glass at a scale the industry wasn't prepared to ramp up to. And then, the losses that can never be rebuilt. Notre Dame's original rose windows survived 8 centuries of war, revolution, and fire. 3 seconds of glass disappearance, and the lead framework is still there, bent and empty, but every piece of medieval glass is gone. When the glass returns, it returns as puddles and lumps on the cathedral floor, mixed and fused, the colors blended into meaningless swirls. Chartres Cathedral, Sainte-Chapelle, York Minster, Canterbury, Cologne. Every piece of stained glass made before the 20th century represents techniques and materials that, in some cases, literally cannot be reproduced because the specific mineral compositions and hand-blown irregularities were products of their time. The glass art of 900 years dissolves into puddles in 3 seconds. It would be the single largest loss of irreplaceable cultural heritage since the destruction of the Library of Alexandria. Except this time, we know exactly what was lost, because we photographed all of it, through glass camera lenses that no longer exist. The world after glass is a world that suddenly understands what glass was doing. Glass was the barrier between you and weather, between you and insects, between you and ultraviolet radiation, between you and wind. Glass was the lens that corrected your vision, the fiber that connected your continent, the container that kept your medicine sterile, the screen that showed you the world, the mirror that showed you yourself. Glass was doing 100 critical jobs simultaneously, and it was doing all of them invisibly, because transparency was the entire point. Rebuilding starts with the furnaces. Glass production requires melting sand at temperatures above 1500 degrees Celsius in furnaces that run continuously, sometimes for 15 years without shutting down, because restarting them after they cool risks cracking the refractory lining. Those furnaces are still standing, mostly, because they're built from refractory brick, not glass. But their monitoring instruments had glass components. Their temperature sensors used glass housings. Their output quality depends on optical measurements made through glass viewports. Still, raw glass production could restart within days to weeks at facilities that suffered minimal structural damage. The problem is priority. What do you make first? Window glass for hospitals? Fiber for internet cables? Lenses for the 2 billion people who can't see? Vials for vaccine storage? Lab glass so scientists can do basic chemistry? Screen glass so the world's 3 billion smartphones work again. Every sector is screaming for glass simultaneously, and global production capacity before the event was calibrated to replacement demand, not total rebuild demand. The flat glass industry produces roughly 12 billion square meters per year under normal conditions. The world's windows alone represent far more than 1 year of production. Fiber optic cable manufacturing capacity can produce maybe 500,000 kilometers per year. The destroyed submarine cable network alone was 1.4 million kilometers. Screen glass production at the Gorilla Glass level involves ion exchange chemical strengthening processes that themselves require glass vessels. At every turn, glass production depends on glass that is already made, creating the same bootstrapping trap. So a month out, most windows in the world are still empty holes covered with plastic sheeting, plywood, or fabric. Internet between continents runs through a patchwork of satellite links, running at a fraction of former bandwidth. 2 billion people are wearing empty frames, or squinting through improvised pinhole devices. Fresh produce prices have tripled or quadrupled in regions dependent on greenhouse agriculture. The semiconductor industry's most advanced fabrication lines are idle, waiting for mirrors that won't arrive for over a year. Hospitals are rationing medications that were stored in glass and contaminated when it reformed. Museums are cataloging which pieces of ancient glass art were completely destroyed versus partially recoverable. Every car on the road has plastic sheeting taped over where the windshield was, and the lumps of glass are everywhere. On sidewalks beneath windows, in the footwells of cars, on laboratory floors, across greenhouse fields. Perfectly good glass, chemically identical to what was there before. You could pick up a lump from beneath an office window and confirm it's the same soda-lime glass that was keeping the rain out 10 minutes ago. It even weighs the same total amount. Nothing was lost, nothing was added. The material just forgot its shape for 3 seconds and let gravity turn every precisely engineered form into a meaningless blob. Every window into a lump, every lens into a pebble, every fiber into a bead, every screen into a puddle. There's a lesson buried in those lumps that goes beyond glass. The raw material was never what mattered. Sand is everywhere. Glass is cheap. What was expensive, what was irreplaceable, what held civilization together was the shape. The specific curve of a corrective lens, the precise thinness of a 5-micron fiber, the engineered flatness of a pane, the parabolic surface of a telescope mirror polished to a fraction of a wavelength of light, the artisan's hand that placed a piece of cobalt blue glass into a lead cane in a French cathedral in the year 1140. All of that knowledge and craftsmanship poured into giving form to a material that is, at the molecular level, just frozen sand. 3 seconds was enough to erase every shape that centuries of human ingenuity pressed into it. And the sand just sat there, transparent and patient, waiting to be shaped again, not caring what it had been, not remembering what it was for,